radicals having the same radical and the same index. To add or subtract similar radicals, we simply add or subtract their coefficients and annex to the sum their common radical part. And then we have an example here, which is, we will show you how to solve this one, and Villusilio will going to show you. And then, now,
first going to do is you look the radicand if there are similar or dissimilar. First, copy the radicand. 3 plus 5 minus 8 plus 4. And second, you look at the radicals. If there are common, you simply copy square root of x. And third, you get the answer of the coefficient. 3 plus 5 minus 8 plus 4. So 3 plus 5 minus 8 plus 4. The answer is 4 minus x. This is our final answer.
okay, thank you.
I'm going to solve problem number 2. First we're going to do is, you are going to look at the radicands. As you can see, our radicands are unlike. So, we're just going to copy this because they're unlike. Mn minus m plus n. Then we're going to intersect with a close and open parenthesis. Then you're going to look at the radicals. As you can see, our examples radicals are like. So we're just going to copy this. Square root of x, y. Then, as you see, our coefficients are unlike. So we can no longer simplify it. So, this is our final answer.
Two examples which is more difficult than this one. I will give you also the key concepts of it. If the radicals to be added are dissimilar, then whenever possible, we may transform first before this into similar radicals before performing addition. Now, we will solve this one, and we will solve first the last example, because this example is more difficult than this. And let's try first this one. And then Kabulaw will show you how to solve this one. And then I will also help him because it is difficult, and this one also is difficult. So we are going to be united. Then I'm going to solve the problem, and Jacoma will explain. Okay, now you see how Kabulaw solved this one.
Wow, he's so intelligent.
Wow, a mathematician, look alike.
Like Mr. Einstein.
A genius man.
March month.
Okay, we will wait until he finish this one.
We will do it Christmas.
Nawaan mo ako sa camera. I'm done solving, so Jacoma will explain. Okay, now thank you Mr. Kabulaw. This is how Kabulaw solved. So let's check if his answer is correct, if his solution is correct. Now, first, square root of 8x minus square root of 18x plus 4 square root of 32x. Since 8 is good in factor, so the factor of this one is 4 times 2x, and then minus this one, the number factor of 18x is 9 times 2x plus radical 4, copy, and then the factor of the factor of 32x is 16 times 2x. And then, since it is now some numbers here, the radicals here are can we simplify it? And then, square root of 4 is 2. And then, copy square root of 2x minus square root of 9 equals 3. So, square root of 2x copy plus radical 4. And then, times, we will multiply this one, radical 4, multiply the square root of 16. The square root of 16, which is 4, multiply by 4. And then copy square root of 2x. And then the result there, copy 2 square root of 2x minus 3 square root of 2x. And then we will multiply this one. 4 times 4 equals 16. So plus 16, copy square root of 2x. Since it is now same in radical, now we will first subtract or add the remaining radical. And then 2 minus 3 plus 16. Since it is like radical, so we will copy this one, square root of 2x. And then, now we will simplify this one. 2 minus 3, negative 1. Plus, negative 1 plus 16 equals 15. Then copy square root of 2x. So our final answer is 15 square root of 2x. And the answer of Cabulao, Mr. Cabulao, is correct.
Santillan Blair B. And then I solved this na number 3.
Okay, thank you. Here is the solution of Mr. Santillan for the problem given. Cube root of 27a raised to the power of 4 minus cube root of negative 64a raised to the power of 7 plus 5 cube root of a. And then he simply first simplify the or factor the variable. Cube root of 27a cube times a minus cube root of negative 64a raised to the power of 6 times a, because he factor first the variable, plus copy this one, 5 cube root of a. And then here the cube root of 27 is 3. Since it is perfect, then we simply get out of this for the square I cube root. And then the result of this one, 3a, because the power of a here, which is 3, we simply divide it by the index, which is 3, and then the result is only 1. But since it is now, we cannot only write 1, so we will write a. 3a cube root of a minus the cube root of negative 64a raised to the power of 6 is negative 4a squared. Here it becomes 2 because 6 divided by index, which is 3. And then the sign of this negative 4, which is the cube root of negative 64, is negative sign. And then copy cube root of a plus 5 cube root of a. And then he multiply this one. Negative times negative equals positive. And then here is his final answer. 3a plus, because negative times negative, it becomes positive. Copy 4a squared plus 1 radical here plus 5. And then since you look that it is same in radical, then we can simply copy this one. And here is the final answer of Santillan's solution. 3a plus 4a squared plus 5 enclosed by open and closed parentheses, copy cube root of a. And his final answer is correct. And then, by the way, I'm Jacoman.
This group.
Okay, we are the Jacomas group, and then the one who
Take a
naway mong now. Okay, I hope that we hope that we make it correctly, even though we have some mistakes about it, but we try our best, and good luck. Thank you.
Thank you.
I love you, ma'am.
I love you, ma'am. Love you.
Thank you.
The video.
The one who take the video which is Madridondo, and you see his face